Hello students, welcome back to maths class. So in the previous session we discussed about signs of trigonometric functions in different quadrants. So I hope you remember that the trick ASTC, all positive, sine positive, tan positive and cos positive. Okay. So today we will see some questions related to the concept of signs of trigonometric functions in different quadrants. Okay. So let's see the question. If cos x is equals to minus 1 by 2, the value of cos x is minus 1 by 2, x lies in the third quadrant. X lies in the third quadrant. Find the values of other 5 trigonometric functions. What is given here? Cos x is equals to minus 1 by 2, the value of cos x is given and it is negative. X lies in the third quadrant. We have to find the values of other 5 trigonometric functions. So, what is given? Given cos x is equals to minus 1 by 2 and it is also given that the angle x lies in the third quadrant. That means x is greater than pi and less than 3 pi by 2. X is greater than 180 degree and less than 270 degree. Okay. So, we have cos x is equals to minus 1 by 2. Now, we can find the value of sec x very easily because sec x is the reciprocal of cos x. So, sec x is equals to, we know that sec x is equals to 1 by cos x. So, we can write sec x is equals to minus 2, the reciprocal of minus 1 by 2, that is minus 2. Now, we will find sin x. We know that sin square x is equals to 1 minus cos square x. Sin square x is equals to 1 minus cos square x. So, we can write, just put the value of cos x here, that is 1 minus, what is the value of cos x? It is minus 1 by 2. So, minus 1 by 2 whole square. So, it will be 1 minus 1 by 4. Okay, that is equals to 3 divided by 4. 4 minus 1, 3 divided by 4. Okay. So, we got sin square x is equals to 3 by 4. So, we can write sin x is equals to plus or minus root 3 upon 2. But here sin x is plus or minus root 3 by 2, it is not possible. Why? Because this x lies in the third quadrant and we know that in the third quadrant sign is negative. You have to remember the rule of signs, that is just you have to remember this ASTC. In the first quadrant all positive, second quadrant sign positive, third quadrant tan is positive. So, here x lies in the third quadrant. In the third quadrant tan is positive and cot is also positive. So, here x lies in the third quadrant, so we have to take the negative value of sin x. There sin x is negative. Okay. So, sin x will be equals to minus root 3 upon 2. So, we got sec x and sin x. Now, we will find the cosec x, that is the reciprocal of sin x. Okay. So, cosec x can be written as, it is the reciprocal of sin x. So, it will be minus 2 upon root 3. Okay. Now, we will find the value of tan x. What is tan x? We know that tan x is equals to sin x divided by cos x. So, just put the value of sin x. What is the value of sin x? That is minus root 3 upon 2. Then, what is the value of cos x? Cos x is equals to minus 1 by 2. So, it is minus 1 by 2. Just simplify it, you will get root 3. So, the value of tan x is root 3. Here x lies in the third quadrant and in the third quadrant tan is positive. So, we also got the positive value of tan x, that is equals to root 3. And what about cot x? Cot x is equals to, now we have to find the value of cot x and we know that cot x is the reciprocal of tan x. Okay. So, cot x is equals to 1 upon root 3. Okay. So, we got all the values here. See once again, sec x is the reciprocal of cos x, so sec x is equals to minus 2, and sin square x, we know that sin square x is equals to 1 minus cos square x. In this way we will get sin square x is equal to 3 by 4 and sin x is equals to plus or minus root 3 upon 2. But x lies in the, it is given that x lies in the third quadrant. So we have to use the rule of sign, that means plus or minus, okay, ASTC. So in the third quadrant sin is negative, so we have to take the negative value of sin x here. So sin x is equals to minus root 3 upon 2, and the cos x is the reciprocal of this minus root 3 upon 2, that is minus 2 by root 3, and tan x is sin x divided by cos x, so it is root 3, and this cot x is the reciprocal of tan x, that is 1 by root 3. In this way we got all the values of other trigonometric functions. Here cos x is given and we find out the other trigonometric functions. Okay. Now let us see one more question. If tan x is equals to minus 5 by 12, x lies in the second quadrant, find the values of other 5 trigonometric functions. So what is given here? Tan x is equals to minus 5 by 12. The value of tan x is given and it is minus 5 by 12, it is negative. Okay. So x lies in the second quadrant, that is also given. We have to find the values of other 5 trigonometric functions. So here given tan x is equals to minus 5 divided by 12. Okay. So here we can directly find the value of cot x, because cot x is the reciprocal of tan x. So cot x is equals to minus 12 divided by 5, as we know that cot x is equals to 1 upon tan x. So it is the reciprocal of minus 5 by 12, that is minus 12 by 5. Okay. Now we know that 1 plus tan square x, 1 plus tan square x, that is equals to sec square x. So we can write sec square x is equals to 1 plus tan square x. Why? Because the value of tan x is given, that is why I am using this formula. Sec square x is equals to 1 plus tan square x. So just put the value of tan x there. Tan x, value of tan x is minus 5 divided by 12. So minus 5 by 12 whole square. So it is 1 plus minus 5 square, that is 25, and it is 144. 12 square is 144. Now we can write sec square x is equals to, we will get 144 plus 25, that is 169 divided by 144. Now sec x is equals to plus or minus square root over 169 divided by 144. So what is the square root of 169? That is 13. It's 13 square. Okay. And 144, it is 12. But what is given? Here sec x, we got the value of sec x as plus or minus 13 by 12, but x lies in the second quadrant. So we know that in the second quadrant, what is the rule? ASTC. In the second quadrant, sign is positive. So what about sec x? Sec x is negative there. Cos x is negative in the second quadrant, so sec x is also negative. So but x lies in the second quadrant, so we will write sec x is equals to minus 13 divided by 12. In the second quadrant, sec x is negative. Okay. So here from we will find the value of cos x, that is the cos x is reciprocal of sec x. So we will write minus 12 divided by 13 cos x. Okay. Now we have to find the value of sin x. We got the values of cot x, sec x and cos x. Now we will find the value of sin x. Here sin x, we can also use the formula sin square x is equal to 1 minus cos square x, because we know the value of cos x. But we can also find in this way, we can write sin x as tan x into cos x. Is it correct? Tan x into cos x. because we know that tan x is sine upon cos. So sine upon cos into cos x, that is nothing but sine x. So sine x can be written as tan x into cos x. So it is better to use this one here because we know the value of tan x and cos x. Okay. So the value of tan x is minus 5 by 12 into what is the value of cos x, that is minus 12 by 13. So it is minus 12 divided by 13. So 12 will be cancelled out, minus minus plus, it is 5 divided by 13. So the value of sin x is 5 upon 13. Okay. Now only one trigonometric function is left now, that is cosec x. That is very simple. Cosec x is the reciprocal of sin x, that is 13 upon 5. Why? Sin x is 5 by 13, so cosec x will be equals to 13 by 5. Here x lies in the second quadrant. So let us check. In the second quadrant, tan is negative, cot is negative, sec is also negative, cos x is negative, cos x is also negative, whereas sin is positive and cosec x is also positive. So these are the values of other 5 trigonometric functions. Here tan x is given and we find out the other 5 trigonometric functions. Okay, clear? So let us move on to the next concept of this lesson, that is trigonometric functions of sum and difference of two angles. Trigonometric functions of sum and difference of two angles. Suppose there are two angles x and y. Okay. Now sum of the angle is taken as x plus y and the difference of the angle is taken as x minus y. Now we will discuss the trigonometric functions for the sum of two angles and what for the difference of two angles, like cos of x plus y, cos of x minus y, sin of x plus y, like that. Okay. So first of all, the first formula under this concept is cos of x plus y. Cos of x plus y is equals to cos x into cos y minus sin x into sin y. For two angles x and y, cos of the sum of two angles, cos of x plus y is equals to cos x into cos y minus sin x into sin y. So this is the first formula for the trigonometric functions of sum and difference of two angles. Now how to prove this formula? Okay. So for the proof of this formula, consider a unit circle of radius 1 unit. Unit circle means of radius 1 unit centered at the origin. Okay. Now take 4 points on the circumference of the circle. P1, here it is the P1, point P1, point P2, point P3 and point P4. Okay. So here this angle P1OP4 is taken as x. It is measured anti-clockwise. It is taken as x. Okay. And the angle P1OP2 is taken as y. It is also measured anti-clockwise. And the angle P4OP3 is measured clockwise and it is equals to minus y. It is taken as minus y. That means the magnitude of the angles P1OP2 and P4OP3 are same, but the direction are different. It is measured anti-clockwise, it is measured clockwise. Okay. Now what is the angle P4OP2? P4OP2 is this angle. So it is the sum of the angles x and y. So this angle is taken as x plus y. Okay. Now I told you in the previous class, if P1 is a point on the circumference of the circle then the coordinates of this point can be represented in terms of cos of the angle x and sine of the angle x. X coordinate is represented by cos x and the y coordinate of the point P1 is represented by sine x. In the same way, the coordinates of the point P4 is 1, 0, okay, because this length is 1 unit now. It is a circle of radius 1 unit. So, the coordinates of here, coordinates of points P1, P2, P3 and P4 are, what are the coordinates of P1, the point P1, because the angle P1 or P4 is x, it is angle x, so it can be taken as cos x comma sin x. Then the coordinates of the point P2, here it is P2, so what is the angle P4 or P2? This angle is x plus y, so here the coordinates of P2 can be taken as cos of x plus y comma sine of x plus y, okay. Now what are the coordinates of the point P3? What is P3? Here this angle is measured clockwise, so the angle is taken as minus y, so the coordinates of the point P3 can be taken as cos of minus y comma sine of minus y, okay. So it can also be written as, the coordinates of P3, we know that cos of minus theta is cos theta, so cos of minus y is cos y and sine of minus y is minus sine y, sine of minus theta is equals to minus sine theta, so sine of minus y is minus sine y, and the coordinates of the point P4, that is 1, 0, P4, that is 1, 0. This point lies on the x-axis and it is a circle of radius 1 unit, so the x coordinate is 1 and the y coordinate is 0 there, okay. Now just join the points P1, P3, join P1, P3 and join P2, P4, okay. Now in the circle, just you see in this circle the triangle P1OP3, the triangle P1OP3 is congruent to the triangle P2OP4, okay. The triangle P1OP3, this triangle, because here OP1 is the radius of the circle, here OP2 is also the radius of the circle, okay. Then OP3 is the radius of the circle, OP4 is also radius of the circle. So two sides are equal, two corresponding sides are equal, and the angle P1OP3 is this angle y plus angle P2OP3, and here also the magnitude of the angle is y, it is taken as minus y because it is measured clockwise. So here this angle is the y plus same this one, that is P2OP3. So these two angles are also equal, that is angle P1OP3 is equals to angle P2OP4. So these two triangles are congruent there. Now triangle P1OP3 is congruent to triangle P2OP4. So we know that if two triangles are congruent, then the corresponding sides are equal. So here P1P3 is equals to P2P4. So from this we will get P1 P3 is equals to P2 P4. So if squaring, then P1 P3 whole square is equals to P2 P4 whole square. Okay. Now let's find the value of P1 P3 whole square. So using the distance formula we can find the value of P1 P3 whole square, that is cos x minus cos y whole square, then plus sin x minus of minus sin y, that is sin x plus sin y whole square, and that is equals to P2 P4 whole square. What is P2 P4? That is the square root of, using the distance formula, but square is there, so square root will not be there. So P2 P4, that is cos of x plus y minus 1 cos of x plus y minus 1 whole square, then plus sin of x plus y minus 0. So that is sin of x plus y minus 0 whole square. Okay. Now let's simplify it. Cos x minus cos y whole square, that is equals to cos square x plus cos square y minus 2 cos x cos y, then plus sin x plus sin y whole square, that is sin square x plus sin square y plus 2 sin x sin y. Okay. And the RHS is equals to cos x plus y minus 1 whole square. So we have to write cos square x plus y plus 1 minus 2 cos x plus y, and it is sin x plus y whole square is there only because it is 0. So plus sin square x plus y. Okay. Now we can write this cos square x plus sin square x, that is 1, then cos square y plus sin square y, that is also 1. So 1 cos square x plus sin square x, that is 1, plus cos square y plus sin square y, that is 1. Now it is minus 2 cos x cos y minus 2 cos x cos y plus 2 sin x sin y is equals to, now here the RHS cos square x plus y plus sin square x plus y, that is 1. Okay. And the remaining portion is plus 1 minus 2 cos x plus y. Clear? Now we can write it as, this is 2, just take 2 common from here, so it will be minus 2 is common there. So cos x cos y minus sin x sin y, then that is equals to 2 minus 2 cos x plus y. Okay. So 2 cos x plus y, that implies 2 gets cancelled. Now it is minus 2 also cancelled, so we can write cos of x plus y is equals to cos x cos y minus sin x sin y. So in this way we can prove this formula, that is cos of x plus y is equals to cos x cos y minus sin x sin y. Clear? So this is the first formula for trigonometric functions of sum and difference of two angles, that is cos x plus y is equals to cos x cos y minus sin x sin y. And the second one is cos of x minus y. Now minus is there, cos of x minus y, so it is, the terms are same here, but here it is minus, now it is plus sin x sin y. You see, if it is cos of x plus y, if it is plus, here it is minus, if it is minus here in the x minus y term, then here is plus in between the two terms. Okay. Now sine of x plus y. Sine of x plus y is sine x into cos y plus cos x sine y. And number 4, sine of x minus y is equals to, this is sine x cos y minus cos x sine y. Okay. Once again, cos of x minus y is equals to cos x cos y plus sin x sin y. Now in the case of sine function, sine of x plus y, if here it is the sum of two angles, then in this formula also there is sum in the two terms, and if it is the difference of two angles, then here also the difference is there. That means sin x cos y minus cos x sin y. Okay. So minus is here, minus is same here, plus here also plus. But in the case of cos, if it is here plus, then here it is minus, and if here it is minus, then here it is plus. Just like you have to remember this one. Okay. Now we can also prove these all formulas. It is cos of x minus y. Now how to prove this? Cos of x minus y is equal to cos x cos y plus sin x sin y. Just we can write this cos of x minus y is equals to cos x plus minus y. Now we can use the first formula, that is cos of x plus y, means in place of y we will take minus y. So that is equals to cos x cos y, but here it is minus y, so cos of minus y, then minus sin x, then sin of minus y. Now we know that cos of minus y is equals to cos y, whereas sin of minus y is equals to minus sin y. So it will be plus. So sin x into sin y. Sin of minus y. Sin of minus y is equals to minus sin y. So we will get plus, minus into minus will be plus there. So this is the formula for cos of x minus y. Likewise, we will see sin of x plus y and sin of x minus y also. Okay. Using the formula of cos x minus y, we can also find the value of cos pi by 2 minus x. Cos pi by 2 minus x. So in the place of x, pi by 2 is there. In the place of y, x is there. So we will write cos pi by 2 minus x is equals to cos pi by 2 into cos x plus, it is plus cos sin pi by 2 sin x. Okay. So what is cos pi by 2? That is 0. So 0 into cos x, 0 into cos x plus, what is the value of sin pi by 2? That is 1 into, then it is sin x. So that is equals to sin x. So we obtained cos pi by 2 minus x is equals to sin x. Okay. Cos pi by 2 minus x is equals to sin x. So we can also find the value of sin pi by 2 minus x. Sin pi by 2 minus x. Now for sin pi by 2 minus x, it can be written as, now only we obtained cos pi by 2 minus x is equal to sin x. So sin pi by 2 minus x, consider pi by 2 minus x as a single angle. So we can write it as cos of pi by 2 minus of pi by 2 minus x. Okay. So we can write it as cos pi by 2 minus pi by 2 and plus x. So pi by 2 gets cancelled. So that is equals to cos x. So sin pi by 2 minus x is equals to cos x, and cos pi by 2 minus x is equals to sin x. Okay. These two formulas we obtained from this one, cos x minus y is equals to cos x cos y plus sin x sin y. Okay. So okay students, that's all for today. I hope you understood all the topics that we discussed today. You have to remember these formulae, that is cos x plus y, cos of x minus y, then sin of x plus y, sin of x minus y. These formulae are very important. We are going to use these formulae in most of the questions. So let's meet in the next session. Till then, bye bye. Thank you very much.